Hello everyone, I welcome you all to today's topic Decodified session. Today we are going to talk about James Webb Space Telescope of NASA, which has given amazing results and the scientific community has been mind blown. We are going to talk about this particular topic in the following sequence. First of all, why in news, thereafter about SMACS0723, then about James Webb Telescope, followed by prelims and mains-based practice questions for you guys. But before that, I want you all to be informed about the Mains 8 2022 program by Analyst IAS, wherein you can get help for polity, essay, public administration, and ethics. Do check out the details given over here and apply soon to improve your score in the mains examination and also to avail the early bird discount. Fine. Getting back to the topic, why in news? So the US President Joe Biden revealed one of the first images of the early universe taken from the James Webb Space Telescope. Now, why it is being called early universe? That is because light travels to us way later, right? Because these galaxies or these pictures of the universe, which we are fetching right now, are of very far, very distant celestial bodies, right? So 4.6 billion years ago is where the image we have currently from. Fine. So that's why early universe. So the preview event has been conducted at the White House on July 12, 2022. The first image of James Webb Telescope, known as Webb's first deep field. This is an important thing to remember again. Webb's first deep field is the name of the first image that James Webb Telescope has given us. What this image is of? This image is of a cluster of galaxies known as SMACS0723. So SMACS0723 is name of a cluster of galaxies whose image James Webb Telescope has given us, and the image is being called as Webb's first deep field. I hope it is clear. Now about SMACS0723. SMACS0723, which is also coded like this, you can check out it for yourself, is a cluster of galaxies within the southern constellation of Volans, also known as SMACS0723 or this PSZ1G284.97 to 3.69 is often visited by Hubble and other telescopes in search of deep past. So James Webb is not the first telescope that has actually pictured this particular galaxy. Earlier telescopes and even Hubble telescope has done that. We are looking back in time at this cluster as it appeared approximately 4.6 billion years ago. That's what I've told you already, right? So this image, see, light travels at a certain pace, and there is certain distance we have from this cluster of galaxies. So what we can see today as light has been able to reach us is actually the image of this particular galaxy from 4.6 billion years ago. This is not how it would be looking. This cluster would be looking today. We don't know how it would be looking as of today. But the image we have is from 4.6 billion years ago. That's the amount of time light has taken to reach to us, right? And that's how far it would be. The new image of SMACS0723 was taken by Webb's near infrared camera, NIR-CAM, near infrared camera. The combined mass of SMACS0723 acts as a gravitational lens, magnifying much more distant galaxies behind it. Webb's NIR-CAM has brought those distant galaxies into sharp focus. They have tiny, faint structures that have never been seen before, including star clusters and diffuse features. So I've already told you that this is not the first time that SMACS0723 has been pictured, but the clarity, the quality of the image is completely at a different level as far as James Webb Space Telescope is concerned, right? Now let's talk about cluster of galaxies. So gravitationally bound grouping of galaxies numbering from 100 to tens of thousands. So how clusters of galaxies are formed? If the galaxies are at a certain distance from each other, wherein the gravitational force can work, they attract each other towards each other. and that's why they stay together, right? So, and ultimately forming a cluster. Large clusters of galaxies often exhibit extensive X-ray emission from intergalactic gas heated to tens of millions of degrees. Also, interactions of galaxies with each other and with intra-cluster gas may deplete galaxies of their own interstellar gas. The Milky Way galaxy belongs to the local group, which lies on the outskirts of Virgo cluster. So, our galaxy lies on the outskirts of the cluster called Virgo. So we are part of Virgo cluster, right? Our galaxy's name is Milky Way. I hope all of you already know that. Now about James Webb Space Telescope. What is the James Webb Space Telescope? The James Webb Space Telescope, also called Webb or JWST, is a large space-based observatory optimized for infrared wavelengths, which will complement and extend the discoveries of Hubble Space Telescope. It will have longer wavelength coverage and greatly improved sensitivity. The longer wavelengths enable Webb to look further back in time to find the first galaxies that formed in the early universe and to peer inside dust clouds where stars and planetary systems are forming even today. I would like you all to look at the telescope once again. This is how it looks in the space. Fine. Now, what was the Webb called before it was named James Webb? The James Webb Space Telescope was originally called Next Generation Space Telescope or NGST. It was called Next Generation because Webb will build on and continue the science exploration started by the Hubble Space Telescope. On September 10, 2002, the Next Generation Space Telescope was named in the honor of James E. Webb, NASA's second administrator, and now it's been called as James Webb Space Telescope, right? Fine. So who was James E. Webb? Let's talk more about him. This space-based observatory is named after James E. Webb. His lifetime has been 1906 to 1992. NASA's second administrator he was. Webb is best known for leading Apollo, a series of lunar exploration programs that landed the first humans to the moon. However, he also initiated a vigorous space science program that was responsible for more than 75 launches during his tenure, including America's first interplanetary explorers. How will Webb be better than Hubble Space Telescope? Webb has been designed to look deeper into the space to see the earliest stars and galaxies that formed in the universe and to look deep into nearby dust clouds to study the formation of stars and planets. In order to do this, Webb will have a much larger primary mirror than Hubble, giving it more light gathering power. It will also have infrared instruments with longer wavelength coverage and greatly improved sensitivity than Hubble. Finally, Webb will operate much farther from Earth, maintaining its extremely cold operating temperature, stable pointing, and high observatory efficiency than with the Earth orbiting Hubble. So, James Webb Space Telescope is better in everything and also is placed farther from where Hubble was placed as far as the distance from Earth is concerned, right? Now, what are the goals of James Webb Space Telescope mission? It is going to search for the first galaxies or luminous objects formed after the Big Bang, determine how galaxies evolved from the formation until now, observe the formation of stars from the first stages to the formation of planetary systems, measure the physical and chemical properties of planetary systems, including our own solar system, and investigate the potential for life in those systems. So these are the goals or objectives of this particular mission. The instruments used in James Webb Telescope, the question can come from here as well. So please pay attention. Near infrared camera, NIRCam, near infrared spectrograph, NIRSPEC, mid infrared instrument, MIRI, fine guidance sensors or near infrared imager, and slitless spectrograph, FGS or NIRISS. Fine. So these are the instruments that have been included in the James Webb Space Telescope. A prelims based practice question for you guys is, with reference to gravitational lensing, consider the following statements. Gravitational lensing is an effect of Einstein's theory of general relativity, that is, mass bends light. Your second statement is, it is indirectly sensitive to the amount and distribution of dark matter. Your options are A, 1 only, B, 2 only, C, both 1 and 2, and D, neither 1 nor 2. You have to pick the correct combination from amongst these and put the correct option as your answer in the comment section. Fine. Now let's look at the mains practice question. What do you understand by gravitational lensing recently in the news? You need to answer this particular question in 150 words. Please don't forget to include the utility of gravitational lensing, where all it is being used, those examples, right? To make your answer very relevant and substantiated. All right. Do send in your answers to us on WhatsApp to get them reviewed. This is it for today. I shall see you again tomorrow with another topic, Decodified. Till then, take care and stay tuned. Thank you so much for joining in.
So that's all for today. Stay connected for more.